G'day viewers, this is Troy from Troy's Visual Arts channel. Well, I'm finally ready to test my mechanical TV camera slash monitor out, my NBTV 32 line standard mechanical TV camera monitor. I've pretty much assembled it into a test state. It's not how it's going to be formally set up. Obviously, once I get this camera done and in working state, I'll be putting an enclosure over this whole entire gear, so there's no stray light coming in anywhere. But for testing purposes, this is how it's set up. I don't know if this will actually work or not, due to many factors like the positioning of the lenses and everything like that. Well, for close-up focus, I've put the lens at that distance from the Nipkoff disc. I've put the test subject, which is that dial again, ornament, dial, whatever you want to call it. Put it within reasonable distance from the lens, and I've got it, and I've managed to get it to focus on the Nipkoff disc. Now, of course, I've done some adjustments to the lenses. I've actually had to put a bit of tape on because of the fact that the racking is a bit loose. The lens is a bit loose on the racking. It tends to be tilting over a bit, so I had to tape it back so it looks straight as possible. I've adjusted the photo transistor back so the light pretty much comes down to just a pinpoint and solely focuses on the transistor. Also, to prevent stray side light from coming in due to the nature of the disc, the holes coming to the edge, I've put a bit of cardboard there. It'll probably obscure the first hole or two, hopefully no more. But either way, it'll stop the stray light from going through to the photo transistor, which would muck up the light coming in from the subject that's to be dissected up into picture elements and to be converted to electricity and outputted to my monitor. But anyways, hopefully if this were to work, I should see a crude picture of the dial. What will happen is the dial will be will have some bright light on it. I'm thinking of positioning this torch somewhere where it will, of course, give a decent amount of light, and the dial will be focused on the Nipkoff disc. The pinpoints of light will be focused through this condenser lens system onto the photo transistor. The dissected lines of picture and the variations of brightnesses of the light will get converted to electrical impulses at the photo transistor end, which is powered by 9 volts electricity, and the signal comes through this yellow lead to the LED driver circuit. The LED driver circuit drives this bank of LEDs, which I got from my wooden Nipkoff disc receiver. And here I've got my motor, which is controlled by this motor speed circuit, and it's going to be powered from a 12 volt battery jack, not battery jack, power jack. Now, unfortunately, the holes in the supports that hold the spindle that holds the Nipkoff disc is just a bit too wide, and once the Nipkoff disc reaches a certain speed, it will wobble. So I have to literally keep my finger on the spindle to keep it rock steady as possible. But anyhow, yeah. So I'm going to test it out and hope for the best. So yeah, stay tuned for the next video, which I'll reveal the results. This is Troy from the Troy Visual Arts channel, signing out.